Okay, let's continue further. Now in the second part of the video, I would like to explain the remaining topics. The first one is when values are passed from the function call to the function definition, or when the arguments are passed to the parameters, the mutability or the immutability of the data types makes a difference, right? So whenever you have a function call, the values are being passed from the arguments to the parameters, right? So they behave differently based on the mutability nature or immutability. In class 11, if you could remember correctly, we have learned a little bit about a data type being, a certain data type being mutable and certain type to be immutable. Let's recall the concept first, otherwise the following the topics will be little puzzling, right? So we'll just revisit the very definition of mutable and immutable. And I'm sure you will be able to remember the integers, the numeric data types are immutable, and then the tuple, so these are some of the examples of the immutable data type. On the other hand, we have the list and the dictionary. They are mutable in nature, right? But we'll just try to understand first regarding the mutable and the immutable thing, right? So the topic will be the mutability, just write this, mutability and immutability of the past object, right? So we should have a clear sight of the goal, right? Okay, I think it's better to note it down. Now let's say you have an integer values, okay? You have a data space with integer values like, say you have 0, right? And then you have 1, and then you have 2, and then you have 3, okay? So first things first, we are trying to understand what mutable means and what is non-mutable or immutable, right? And then each of these should have addresses, memory addresses. It's a data space in which the values are stored, the integer values are stored, right? Let's say you have 100, this is the address, and then 104 indicating that, just as an example, each integer occupies 4 bytes of memory spaces, and then let's say you have 108 and then you have 112. So these are the integer values which are stored in the location with the addresses, the memory addresses of 100, even though the memory address will be pretty lengthy, but just to keep the example as simple as possible. So now let's say you have expression of a is equal to 0, alright? Now what happens is, whenever you have a value in the value of 0 which is assigned to a, what happens is, the variable in Python is not a storage container. It's not like C++ or Java where the variable is considered as a storage container in which the value is stored. Rather in Python, this is important. Variable in Python is a reference to a value which is stored in a memory location. Okay, so if this is the statement, what happens is, a, like I said, is a variable in Python which will refer to this. Okay, it will just refer to this. So the variable in Python is a reference to a value stored at certain memory location. Okay, it's like a pointer, it just points to, right? Now let's say I change or I increment the value of a by 1, okay? A is added, with a value of 1. So what happens here is, now at this time, the value of a actually changes from 0 to 1. So, at this time, this particular pointer, a will now point to this. Okay? So, initially, a stores the address of 0, which is 100, right? But since I've made some changes, since I've added 1 to it, a will now point to 104. It will point to 104 because it has the new value of a, which is 1, right? So when I say a is immutable, integer is immutable means the same value in the same memory location cannot be changed. Earlier, the value of a is 0. When I changed 0 from 1, the value in place cannot be changed. Rather, the variable is made to point to the updated value of 1, right? So, since these integers values cannot be modified in place, now this word is important, in place, the variables are made to point to the address, a new address which has the new value. Okay, so this is the reason why we say that a or integer or numeric the values are immutable in nature. This particular value cannot be changed. Now, it looks like if you try to look at the statements, when you print the value of a, looks like the value of a has been changed from 0 to 1. But technically, what happens is the value in place, the same value in the same memory location cannot be changed. Rather, the a is made to refer to another address with the updated value of a, right? So this is the case with integer. Now, let's understand why this is mutable. Now, this is immutable, right? So I'll just write here immutable, right? So this will help you to remember. In place means the value in place cannot be changed, hence it's immutable. Let's take an example of the list. But let's say I have a variable called list, alright? List is equal to, let's say you have 2. Okay? Now, when you have such a statement, what happens is, again, a variable with a list will be created, right? So this will again point to another address. Okay, this will point to another address like this. Okay, now let's say the address is 200. Okay, so now since this particular list is pointing to this list, this particular memory location. And this, what happens is, you will have the address of the individual element. Okay, you will have the address of individual element, right? So the individual element of list is 2. Where is 2? 2 is stored in the memory address of 108. So what happens here is, you will have 108. Okay, so this 108 will point to this memory location, right? So now the situation is, where is list? This is the variable called list, alright? So just like a, it should point to a certain memory location. So it points to the memory address of 200, right? So in this list can have several elements, right? So as of now, it just has only one element, 2. Okay? So inside this, again, you will have address of integer value of 2. The integer value of 2 is stored in 108. So you will have 108, which means the address of the individual element of the list is 2. And it has the address of 108. Now let's make a change. Let's say I add list of 0, okay, is equal to list of 0 plus 1. So list of 0 means you're talking, you're referring to the first element, right? So you add 1, it becomes how much? It becomes 3, right? Now what happens is, you see this reference will not change. It will not change. Rather, 108 will now change to 112. Okay, why this will change to 112? Because the new individual element of the list is no more 2, rather it is 3. So in the process, this will now point at 112, right? Now coming back to the question, why list is mutable? Look here, list is all the time referring to the memory address of 200. You see this? It is all the time referring to 200, right? So when you make a change, what happens? The changes are taking place inside the memory address of 200. But from the point of list, the address of 200 never ever changes. So it looks like as if the changes are taking in place. The reference always remains, okay, and appears to our eyes that the changes could take place inside, the memory location of 200, right? So when you see the difference between the two, the moment you make a change to integer variable like a, the address, 100, initially it's 100, it now changes to 104, accordingly it could change to 108, but the list, it will always refer to the memory address of 200. Any changes that you make will be affected in the memory addresses of the individual elements of the list. Any changes you make or apply to the list will take place to the memory address of the individual elements of the list, right? So when you look at this, this is the immutable, okay? You cannot change the values in place, but when you look at the list, it looks like, in fact, you can have changes in place, right? Hence, this is called mutable and this is called immutable, right? So once you have understood the concept of mutable and immutable, let's move on to the next example, right? Just drop this. Okay. Okay. Now, the example could be like, let's say you have a function by the name of def, right? Okay, and then you have f1, and then we'll receive the parameter of b, okay, and then b is equal to b plus 1, right? And then I just print a message, say inside, okay, f1 function, inside f1 function, b is equal to b. Okay, so this is the function of f1, and then the main part of the program, let's say you have a is equal to 2, right? And then let's call the function, okay, or maybe perhaps just right here, print inside main, okay, or to make the program a little shorter, before function call, okay, a is equal to a, and then let's call the function f1 and I send the argument of a, right? And then we'll just print after function call, okay? In order to save time, I'll just keep it short. After the function call, a is equal to a, right? So this is the main part of the program, right? So what happens is, so let's try to figure out how the local or the global environments are actually created. At the same time, we'll try to refer to the data space, right? So you will have something like this. Again, you will have here 0, you will have 1, you will have 2, and then you will have 3. So 100, 104, 108, and then you have 112. Okay? And then, now this is the data space, right? And then you have the, what is this? This is the global scope. Okay, this is the global scope or global environment, right? Global environment, and then in the global environment you have A is equal to 2. Okay, so what happens is this A will point to the memory address of 108, because in the memory address of 108 you have the value of 2. So this is like the data space. Okay, and then once you have the function call, what happens is a local environment will be created. Okay, so this is the local environment for the function definition of f1. Alright, so in this, a b variable will be created, right? So initially, when the value of a is passed to b, what happens is b will also point to this. Okay, so you have a and b, both are pointing to the same memory address which has the integer value of 2, right? So you need to understand this. Okay, and then now the next step is the value of b is being changed. The value of b is being changed. 2 plus 1 is 3. So the new value of b is 3. So what happens is, since integer variables are immutable in nature, the value in place cannot be changed. Rather, the b will be made to refer to some other address, right? So this b will now point to 112. The reason is 112 will have the new value of b, which is 3. Okay, and then you have the print statements, right? So this will give us the output of, okay, inside f1, b is equal to how much? It will be 3. Okay, and then once the printing statement is done, the whole thing disappears. Remember, okay, the local environment will be removed from the memory, from the computer's memory, right? So the whole reference, they all will disappear, and then come back. Okay, once after the function call, you come back and then print. After call, this statement should be printed, right? Initially, you should have before, and then you have, okay, first you should have this, right? So before call, a is equal to 2, right? Okay, so once the function has been executed, I come back to the function call, then you will have this. Okay, after call, you have after call, a is equal to, look at this, the value of a. The value of a will still be 2. Okay, the value of a will still be 2. So, through this program, what you should know is, whenever the arguments, when the values are passed from, look at this, when the values are passed from the actual argument to the formal argument. Okay, so this is the actual argument, this is the formal argument, right? If it's mutable, you will see a change in the original value of a. If it's immutable, you will not see the change, right? Look at this. Initially, when you print the value of a, what happens? It's 2, right? It's 2, and I sent the argument to the parameter. I made some changes, right? Since it's immutable, after the function call, when you try to print the value of a, it will still remain as 2. The reason is the integer variables are immutable in nature. They cannot be changed in place. All right. So you need to know this. The behavior changes depending on the mutability type of the values which are being sent. So as of now, I've sent immutable data type, because of which whatever changes you make up, the changes are not reflected back to the original values. Okay, so this is regarding the past object being integer. Right? Now let's move on to the second category. Okay, I hope you got the first one, right? So basically you're trying to send the integer value from A to B. Now let's focus on the next, the program. Just mark this. The second example will be passing the mutable. Okay, so that's going to be the list. So we'll be sending the list. In the earlier example, we have sent the integer. Now we'll send the list, and then we'll check how the behavior changes. Right. So let's say again you have the function of f2 this time, and then I'll have a list by the name of my list. Okay, and then I want to make some changes. Say my list, okay, is equal to, how do I make changes? Now let's say if I write, or perhaps my list dot append, okay, and then append with, let's say 3, okay, and then print inside F2, and then try to print, okay, or we'll just make it a little interactive. Inside F2, my list is equal to my list. Okay, what am I doing? Okay, good enough. I cannot have this actually. Okay, something like this. And then I should have a comma, right? Okay, so this is the function of f2, and then let's focus on the main part of the program. Let's say I have list is equal to, and then I'll have 1, comma, and then 2. So you have two individual elements, 2 elements in the list, right? And then let's print, you know, the, okay, before the function call, before, I just write call, right? Call, okay, before call, you know, the list is equal to list, okay? So before the call, we are just checking, you know, the content of the list, and then let's make the function call, okay? F2, this is the name of the function, and then I'm sending list. Let's call the function, and then we'll try to print, and then this time it will be after call, and then list is equal to list, right? So let's trace the local and the global environment, right? We'll just try to come up with the drawing, right? Okay, so again, I'll just come up with the data space. The data space should actually be outside, so it has to be like 1, 2, and then 3, and then it'll be 4. Okay, let's get rid of 0, and then as usual you will have 100, 101, 100, 104, 108, 112. These are the addresses, right? So the moment Python interpreter executes this, it creates the global environment, right? It will create the global environment, right? In which you have this list, right? So I have the list, and this list will now refer to another address, okay? It will refer to another address like this. Alright, which will have, let's say, the address of 200, right? And then in this list, I have how many elements? I have 2 elements, 1 and 2, right? So you have the index. Remember, index as 0 and index as 1, okay? So something like this. So the first element, you know, the first element is 1, and the 1 has the address of 100, right? So just aside to the index, you will have the address of the first element. Okay, so these are the index. So you have the address of the first element with the index of 0, right? So this will now point to this 100. Okay, it's easy, right? And then you have 2, right? And 2 resides in the address of 104, right? So this will point to the address of 104. Okay? So once you have this, once you're done with this, you have the printing statement. It will be like before call. Okay? So before call, list is equal to, you will have 1, comma 2. Okay? And then you have the function call, hence the local namespace will be created like this. Okay? Local namespace for the function of f2. Okay? And then you are passing, the list to my list. You are passing the list to my list. What is it that you are passing? You are passing the address or the reference. You are passing the reference. So the list is referring to the storage location whose address is 200, right? So you will now have my list, okay, which will also point to 200, okay, which will also point to the memory location which is being pointed to by list, right? So from list to my list, from argument to this parameter, you're passing the reference, right? So this reference is being passed to the my list, which means both list and my list will now point to the same address, okay? And then my list.append, you're making some changes to the my list, right? You're making some changes to the storage location of my list, right? So the changes you are appending or you are adding 3 to it, right? So what happens here is, I'm sorry, it's a little messy. Okay, so what happens here is it will now add the index of 2 and then the memory address of 3, which is 108. Okay, like this. Understood? And then once you're finished with this, you have added, the individual element of 2, whose address is 108, which means this will now point to, okay, this particular memory location, right? And then it's time for the print statement. So this will print like, I won't write the entire thing. Inside F2, the my list will be, it will be 1, 2, and 3. Okay? So once you're finished with this, the local environment will be removed from the memory location. And then, from here, the next step is this particular statement, right? So after the call, okay, when you print the value of list, it will now be 1, 2, and 3. Okay, so it will be 1, 2, and 3. Okay, so what did you understand from this program, or what difference did you notice from the earlier program? Now, since list is a mutable data type, when I sent the values of list to my list, and then in the function definition, I made some changes. In fact, I added 3, as the next element, right? And then when I printed, it printed as 1, 2, 3. But after the function call, when I referred to the original list, when I printed the content of the original list, it still came down to the list content with the new values. So it printed 1, 2, 3. In the earlier program, the changes that you made in the function definition have no reflection, have no effect to the original value. But this time, since the list is mutable in nature, the changes made to the list in the function definition of F2 are indeed reflected in the original content of the list, right? So when you run the program, 1, 2 is sent up, I added 3 I printed the content of my list in the function definition, it showed 1, 2, 3, and then coming back to the main part of the program, when I printed the original value of list, it did show the updated or the changed. So this clearly tells us that when you send integer from the argument to the parameters, no matter you make any changes up there, the changes will not be affected in the original values. But if you send the mutable data types like the list up in the function definition, and then any changes will be on a permanent basis. And then how all this happened could be understood through the diagram. Alright? So this is the second the case or the second program. Okay, let's now write the program for the third option or the third example. So let's do this real quick. Say now this time the name of the function will be f3, and then again I have the parameter called my list. Alright, now this time I have a new list with the value of, let's say, 4. Okay, and then I assign my list with the new list. Right, and then I make some changes like this, my list, right, and then perhaps I could just append another value with 5. All right, and then I print the my list. Okay, my list is equal to my list, right? Just print it, and then so this is the function definition, and then we have the main part of the program as, let's have the original list is equal to, let's say we have 2 and 3. Okay, and then okay, we'll not print it, we'll just make the function call. Right, so the function call will be f3, and then I send the list. All right, this will be received by my list, and then I print the value of list. Okay, so I've just simplified the program in order to save time. Now let's see how the memory location will look like. So you have the data space. So this is the data space. It will be, I'll be starting from 2, right? So 2, 3, 4, 5, and then 6. Do I need 6? Okay, I don't think so. All right, and then each of these will have the address. This is 100, 104, 108, 112, and let's say this is 200. Right? So again, with the execution of the first statement in the global, so this whole thing is a global namespace, and then in this you will have the list, right? The original list, and then this will be pointing to this. Okay, so this will be pointing to this. Okay, 200. All right, and then in the 200. You will have 2 index. You will have 2 index, one for the 0 and then one for the 1, right? So the whole thing address, the whole block address is 200, and then in this you have the address of 2. The address of 2 is 100, and the address of 3 is right 104. Okay. Okay, I hope you're clear with this. And then since this list is being passed on to my list in the local namespace, alright, in the local namespace, now this is the local namespace for f3 function, alright. So you have another, the name of the list is what? It is my list, okay. So this my list will be pointing to the same address of 200, right? So list and my list, they are both pointing to the same address. Now look here. Now this time in the local scope or the local environment of F3, I have again a new list called new. New. So this new, is you have new here. All right. So this new list is pointing to 108. Okay, it is pointing to 108. So once you're finished with this, or in other words, you could say like, or perhaps, I'm sorry, maybe it's better to write here. So I have new list, right? So this is a new list. Now this will, again point to another memory location. Let's say this is 204. Okay, so this new list has only one element, right? So it will have just 0, and then since it's 4 and 4 resides in 108, you will have the address like this. Okay, so till this point, I hope you're clear. New is a new list which is defined inside the local environment of F3, and it points to this. Let's see. Now look at this. New reference. The reference of new, this is how you should say it. The reference of new is being passed on to my list, right? Initially, my list has a reference to 200, right? So my list is now redirected to 204. The address to which the new list is referring to. Look at this. New reference is being assigned to my list. So new reference is assigned to my list, right? So the my list will be made to refer to 204. Let's say I make a change. My list dot append 5. Okay, so I append 5 to this. Where is 5? 5 is stored in memory address of 112. So you will have the new index with the address of 112. Okay. So now this time when you print the content of my list, what happens is this will give us the answer of 108. The value at 108 is 4. The value at 1112 is 5. Right? So we should see an answer like this. When you print the content of my list, it will be 4, 5. Okay. So after the function call, when you print the value of list, list, we will still get, the list is still pointing to 200, right? And in 200 memory address, we have 100 and 104. In 100, what do we have? 2. In 104, we have 3. So we will get the output as this. We will get the output as 2 and 3, right? So do you see a difference between the second program and the third program? In the second program, we sent the content of list to my list. I made some changes. The changes are reflected in the original list. But this time, when I send list to my list, and then I made some changes, but when I check the original value, it is still 2, 3. Okay? The changes which were applied to the my list were not reflected in the original value of list. So despite the list being mutable. So in the program number 3, what you should know is when you send a mutable type, okay, I'll go slow. When we send a mutable type to a function call, if that mutable parameter is assigned with a new name or a new value, then any changes that you make will not be reflected back to the original values. So this is the moral of the story when it comes to the third program. Look here, let's just repeat it. If you send the mutable type to a function call, function definition, okay, as is the case here, list is mutable, I sent the mutable argument to mutable parameter, okay. So just in case, if I assign that mutable type with another value or another data type or another the list or another variable, it could be anything, right? If you do that, the reference changes. Okay, when the reference changes, any changes that you make, will not be reflected, okay, will not have a permanent change in the original values of the list. So you saw here, right? I sent 2, 3 up there. This is supposed to be list. Okay, I made some changes, and then when I came back, when I checked the original value of list, it wasn't changed, right? However, coming back to the program number 2, if I sent the mutable, the type from argument to the parameter, and then you will see a permanent change if the parameter is not assigned with a new name or a new value. So in short, the mutable type will permanently change, if it's not assigned with a new value or a new name, okay? And then it will not change, mutable type will not change if you assign a parameter, past parameter with a new value or new name, right? So this 2, 3 lines, you need to take care. Otherwise, it's pretty simple. The first one is if you send an integer value from the function call to the function definition, no matter whatever changes you make up there, when you come back, there will be no change. Okay, but program number 2, when you send the mutable type like list, you make some changes, the changes will be reflected. And the third is the exception. When you send mutable type like list, however, if that the parameter is assigned with a new value, then the reference changes. If the reference changes, whatever changes you make, will not be reflected back to the original value, right? So these concepts are very, very easy. It's just that they look little confusing at the start, but once you get used to it, it should be a cakewalk, right? So with this, I would like to end my video. Please go through the notes and read it again and again. So once you get it, it should be very easy. Thank you.